All right, welcome to Lecture 3 for Computer Science 4303. As you can see, I've got a little bit of a different layout here, just trying something new. In trying to make this scene, I broke something and thought I wouldn't start the lecture on time, but we got it all started, so that's fine. But let's have a look at where we are in the course. So today is Tuesday, January 19th, and today we're going to be looking over Assignment 1 and Visual Studio. So let's switch back to the bigger view, because in the recording it might be a little bit less clear. So today, we're going to be looking over Assignment 1. If you're using Windows, which in a poll that I did, I think like 70% of people who answered the survey are using Windows, we'll be going over Visual Studio or Assignment 1. Someone asked in the chat if we're using a Mac, should we sign out? No, absolutely not. I will only be going over Visual Studio for about 20 to 30 minutes, and the rest of it will be how Assignment 1 works. So you should stay tuned for Assignment 1, because that applies to everybody. I just want to, I do not work for Microsoft, but Visual Studio is the reason I still use Windows. So it's a very good program. I've released the assignments with a Visual Studio project file, and so that's why I'm looking over it today. Okay, but first, before I get into that, I want to go over the email that was sent out to you over the weekend, because I've gotten a few questions about it. So let's go over that. Let's try and make this a bit darker first. Here we go. All right. So here's an email that I sent out. Let me make this camera a little bit smaller. And let me first give you the context for why this email matters. So in the past, what I've done is I've just thrown up an assignment zip file on my website. And that assignment zip file is downloaded by absolutely everybody. And then you do the assignment and you submit the assignment on D2L. And so there hasn't been a real issue with that system. The system itself is fine. The problem is when you involve humans, especially cheating students. And so in the past 2 years, I have found my assignments on Chegg, I have found them on GitHub, I have found them on this Russian website that sells assignments for $35. I actually bought my own assignment for $35 just to try and figure out who did the solution. I found out who did the solution, and apparently in that particular case, what had happened was that, so here's how I found it. I downloaded the assignment, it didn't work. The zip file was corrupted or something, so I actually had to like get in contact with the shady Russian guy in charge of the website and downloaded the assignment, and I have a database of every assignment that's ever been submitted to me. So I ran that assignment through that one because, of course, all the comments and stuff have been stripped out and people try and anonymize it, but it doesn't work. And so we found the person who did it, and the person who did that assignment got like a 98 in the course. And so I was pretty sure that that person wasn't someone who would like go submit that to a like Russian assignment selling website. So apparently what happened was that that student had made their GitHub public at one point, even for just a few minutes. And so their assignment was available on GitHub, and these Russian bots scrape GitHub all the time for anything that looks like an assignment, and then they sell it on their website. And so I found the person, I contacted him, we tracked it down, what had happened. For like a month, he had it public on GitHub, and then they made it private, but it was already too late. And so when I say that this stuff isn't to go on GitHub, it's very serious. Like, I know that you guys think, oh, Dave is just like, you know, trying to scare us or whatever, but like, these assignments take weeks to make, okay? They're a lot of work. And as soon as a solution gets out there, it's useless for me to give it again, because it's just been solved by people. And the reason people, I think, like my courses is because the assignments are really good. And, well, at least I think they're really good. And they're good because they take a long time to make. And so I can't make a whole new set of assignments every single year. So what I did this year was I said, okay, let's go a little bit more in depth with the cheating protection. So instead of just having a single zip file on my website that everyone can download that is really hard to trace, like if you had just put the assignment up there, there's no way for me to trace that back to you. If you put the solution up there, then there is, right? Because I can compare your code versus other code. But if you had just posted the assignment, which is almost just as bad, then there's no way to trace it back to you. But now there is, okay? So this is, and 99% of people who take my course, this is not relevant to you. You will never do stuff like this. But, of course, when it comes to stuff like this, you know, we have police because of 0.001% of society who wants to mess with people, okay? So this is my attempt to make things a little bit more secure. So here's the email. I'll read it out now. And so the email started with all of your information. So you know that this is legit, right? Obviously, my really lucky student ID is 1 through 9. And you were also given this randomly generated code. So let's just read it and we'll see what this did. Okay. So, due to the rise in cheating, due to classes now being online, I'm now releasing individual assignment zip files to each student in the course. The files included in these zips will contain information unique to you, such as the information listed above. I apologize for the inconvenience, but this has become, unfortunately, necessary step. All right. This is very important, okay? This is probably the most important part of this email. Do not share these links or the code that I gave you with anyone, even your own group members, okay? So that code, don't share it with anyone, because if someone else gets your code and then posts the assignment online, it's going to be traced back to you, okay? That's how this is going to work. So if they get the code and they download your assignment file, then everything can be traced back to you, and you don't want that to happen. And this is a randomly generated 16-digit alphanumeric character. So there are trillions and trillions and trillions. Like, you'll never randomly guess this thing, right? Like, it's even YouTube only uses like 10 digits or something like that. So if you give that out, that's on you. All right. And if it gets posted somewhere online, then I'm coming to you looking for answers. So please don't give that out. But once you've downloaded the zip file, then it's all good, right? You can share that with your group member in order to collaborate. You can put the contents of the zip file on your private GitHub repo in order to work on it, right? So that's fine. So do not share these links or the code above with anyone, even your own group members. If the files get posted online for any reason, they can be traced back to you. Make absolutely sure that if you collaborate using online repos such as GitHub, that you use private repositories. If you post any of these files online or access any other student's download links, it will be considered academic misconduct. Once the zip file has been downloaded, you may share its contents privately with your group members only. Excuse me, I had a cough. Okay, so also you might say, well, you know, what if someone somehow gets my code through hacking my email or something like that? Well, because these are all hosted on my website, and these are now unique URLs, if I absolutely need to, I can go to the department and get the IP address of whoever downloaded this thing, okay? So, and don't try and go through and like get to assignment 1 folder and try to go there. They won't be listed, they won't be searchable, they won't be listable, okay? So you won't know where other people's code is. So here are your personalized links. So save those links. If you can see, there's definitely a structure to these links. So it'll be my website, courses 4303, assignments, and then AN, where N is the assignment number, then your code as a directory, and then an assignment zip file that's named after you. Okay? These links will become active as assignments are released. And the following copyright is also now attached. So before, I had no like legal way to come after you, but now all of these assignments are copyrighted. These assignments are not open source. I completely believe in open source code. I have about 100,000 lines of open source code on GitHub. I've released thousands of hours of my own work for free. I completely support open source software, but these assignments are not open source software, okay? They are for, well, let me read this. Copyright David Churchill, all rights reserved. This is for this assignment specifically, written by me. Unauthorized copying of these files is strictly prohibited, which means that I am giving you authorization to copy the files to your group member only, or to share the code through some private online means with your group member only. So any other form of copying that assignment or hosting it anywhere is unauthorized, okay? Distributed only for work at Memorial University. If you see this file online, please contact the email above. All right. So I hate to have to do that. I hate copyright. All of my other code has been released under the MIT license, which basically says you can do whatever you want with this, including sell it if you want to. But these assignments, there has been a problem in the past with people posting them online. So this is my one and only warning that there will be no excuses for having this posted online. Okay. So that's the email that went out. One of the questions that I got was like, how do we share it with our partners if we're not allowed to? No, you are allowed to share the contents of your code and your zip file with your course partners, but you're just not allowed to share that code, okay? So please don't share the code with anyone. If the codes do somehow get compromised, I can regenerate them trivially, so don't worry about that. And if you did not get an email from me, it means that you were probably joined the class late. So what I did was I used the class list from D2L as of last Tuesday as the email addresses that were sent out, right? So I got your usernames and just sent them to those email addresses. So that's, if you didn't get the file, don't worry. I got 2 emails, I believe, from people who didn't get this email. That will be released after. One question in the chat, maybe a question you can't answer, but how are the contents of your zip file linked to the code? We will go over part of that, and we will not go over another part of that, okay? I will show you, once I go over the files in the assignment, one of the ways in which I have personalized the files to you. Okay. So, well, let me just show you one of those ways now while I'm on topic, I guess. So, for example, this is the assignment structure. I'll be getting into the assignment structure later. But if we look at all the source code that I've given you, if I open up any of the source code files, there is a header at the top of each file containing, along with some ASCII art, your information, okay? So that is now at the top of every file. And I'll go over this later again, but please enter your group members here. Every file in the zip file has been personalized somehow to you. Here is one of the public ways that the file has been personalized to you. I will obviously not be giving out the private ways in which the file has been personalized to you, but there's lots of other stuff going on beneath the scenes that you won't know, because if I tell you, you'll just fix it, right? Are the passwords for the zip file different? There are no passwords for any of the zip files. The codes are for the download links only. You do not need to enter a password in order to unzip your file. Okay, so that's one of the ways. Every one of your files has all your information included in it, so you definitely don't want that going anywhere. And then at the bottom of each file is the copyright that I have included with each assignment. And if you know anything about that, you're not allowed to remove the copyright, right? So legally, if you do post this code online and this copyright has been stripped, then you might be in actual legal trouble, okay? So please don't do that. All right. But let's go back and see what I wanted to do for this class. I've got a bunch of stuff I want to talk about. Okay, so we're going to go over Visual Studio. I'm going to go over a bunch of stuff about Visual Studio. And then I'm going to go over what the assignment is, how the assignment works, etc. And first, I'm just going to make a little blank here so I can make a timestamp on YouTube. Perfect. Okay, so there's a big difference between Visual Studio and Visual Studio Code. I have made this difference a little more confusing by the fact that I actually opened up the assignment in Visual Studio Code here. The only reason I opened up the assignment in Visual Studio Code is because it has a directory listing, okay? So this is just the easiest possible way for me to actually open up all the files, including the README, the make file, the license file, the Visual Studio files. Visual Studio Code is essentially a glorified text editor, okay? I cannot just, there's no compiler built into Visual Studio Code, so I can't compile my source code here. If I had linked in a compiler like GCC or MinGW, then yes, I could use it. But Visual Studio, which I will be showing in a minute, has a fully fledged, compiler built in, and that's what I'm going to be showing now. So let's open Visual Studio. First, before I do that, let me show you the structure of the files in my assignments. If you've taken 4300 with me, this is the exact same thing. So let me just close these things over here. I'll cancel that for a second. So over here, you see the directory structure for the assignment zip file. I could show this like in Explorer, but my Windows font is so small that I don't want to do that, okay? So let me show it here for a second. There's 3 folders, bin, source, and Visual Studio. Then there's 3 files, license, makefile, and readme. So I'm just going to be showing that off inside Visual Studio Code because it has a directory listing that's really neat, okay? And then I will open up the actual Visual Studio project and we'll go over the assignment. So the directory structure, it has 3 folders, bin, source, Visual Studio, and it has 3 files in the top level directory, the README file, the make file, and the license file. So the README file specifies what you have to do in the assignment, and we'll be going over that in a bit. The make file is here in case you are on Mac or Linux and you want a make file. So what a make file is, it's kind of like a project file for Xcode or a project file for Visual Studio. It just tells the compiler where all the files are so that you can, if you have CMake installed, you can just type make and it will compile the whole project for you. I won't be going into how the make file works, but essentially it compiles all the files that have been changed since your last compilation, and then it sticks your executable in the bin directory. Okay, and there's more instructions on how to set that up on the website. There's also the license file. So the license file just includes the copyright for the assignment, as is pretty standard. You include a license.txt whenever you release something online. The Visual Studio folder contains the Visual Studio solution file and the Visual Studio project file, the filters file, and the user file. So these are all just files that Visual Studio uses, which we'll talk about later. But the solution file, that's what you open in order to get Visual Studio to run with your project. The project file is included as part of the solution. So when you open the solution imports that project. And if we want to look inside these files here, the solution file just says, okay, which projects are part of the solution. The project file is kind of similar to the make file. It's just in XML and it's really complicated. And it says like, which files are a part of this project and how do I compile it and what are the options? That's what those files are. Then if you look at the source directory, that's all the actual CPP and H files for the assignment that you will be editing and using. And we won't go into those right now. And the bin folder is going to contain the config.txt file, which we'll look at a little bit later. And it's also going to contain a fonts directory where I've included a font so that SFML can draw some text to the screen. But you don't have to worry about that. It's just a really small sized font file. Whenever you compile anything with either the make file or the Visual Studio project file, all of your intermediary files and your executable will go inside the bin directory. So bin directory is the binary directory, and that's where the files will go. Okay, so that's the structure of the zip file. All of my assignments will have the exact same structure. It's a pretty neat structure, and it's good to get you used to this sort of structure going forward because that's how a lot of projects are structured. Not everyone is the exact same, but they all have some sort of structure that's like that. So now what I'm going to do is over here in the assignment folder, in order to open this assignment in Windows, you go into the Visual Studio folder and you click the a1tron.sln or solution file. Okay, so now we've got it open, and this is Visual Studio proper, okay? And I know that the fonts are super small, but we're going to go over some of the options in how to make that stuff bigger, etc. So let me open up the list of things that I wanted to cover. So the first and foremost thing that you should do when you open up Visual Studio is turn off light mode. Obviously, we're programmers, we use dark mode, right? Who uses light mode? I don't know. But if I find out that you were using anything but dark mode for your assignment, it's minus 5%. Not really, but dark mode is amazing. Okay. So first of all, turn on dark mode. That's the most important step of Visual Studio. Second, we're going to change some of the font sizes, okay? So let me just open up main.cpp here. I have opened the wrong file, so just give me a second. All right, so I need to go. There we go. I've opened the wrong solution, so just let me open that again. Okay, so this, I hope, is mine. There we go. Okay, so this is my assignment file. As you can see, I've got the same header file here with my information and the copyright in all of the source files. So the first thing that we're going to do is I'm going to go into some of the settings so that you can change the font sizes and so that you can actually follow along in this lecture, but if you want to, you can change the font sizes as well. So we're going to go into options here, and I know this is pretty small, but it'll get bigger in a second. And then we're going to go into fonts and colors, and we're going to, so the text editor font, if you click text editor up here, it's the first one. That's where you can change the font for the text editor itself. But if you have the font that you want, if you hold Control and use the scroll wheel, you can make the font size bigger or smaller. So that's what I've been using, is just Control and the scroll wheel. But one thing that I am interested in is this, I want to make the font size over here for the Solution Explorer bigger. So if we go into Environment, then we choose, right now it's set to automatic. So that automatic font size is this font size 9, really, really small thing. And so let me, oh yeah. So Segoi UI, that's the font that Visual Studio uses by default. And let's set that to something, 16 should be fine. So now, let me know if you can see that okay. I think that makes things big enough to see in 1080, right? So you should be able to see that font size now. Just let me know in the chat if that's a lot better. Someone says set it to Comic Sans. Nope. I'm leaving it at the default. Okay. So that's how we change the font size for everything that's not the text. Okay. So that should make these this much easier to read. Now, there are some things over here. You see this file listing, right? So this over here is called the Solution Explorer. So the Solution Explorer is essentially just a listing of all the files that you've added to the project. So this is not a directory listing, right? It's not all the files that I've released with the assignment. It's just all the files that have been specifically added to the project itself. So this Solution Explorer shows you all of those files. So if we look at this real quick, you can see solution A1tron, one of one project. So solutions are what Visual Studio opens, okay? Solutions contain one or more projects. In our case, for this year, we're going to have a single project in our assignments. That project file is going to contain all the code for your assignment. So if we look right here, this is the A1 Tron project. I should have maybe named them a little bit differently, but the solution, that's the a1tron.sln file, and the project is the a1tron.vcxprog file. Inside here, you see a bunch of CPP and H files. That's the assignment. Then you see references and you see external dependencies. So references is something that's used by this like package manager, and I wish there was an easy way to get rid of that because I don't like having it there. Just ignore that. That's not an actual file. It's used by some package manager or something. The external dependencies thing here is like everything that has been imported by our project. And I actually don't like having that there. So I'm going to go into the options and I'm going to search for external and go to C++ advanced. And then down here, it says disable external dependencies folder and set that to true. Okay. So I've set that to true, and now inside my project, you no longer see that big wide external dependencies thing, and so I always turn that off. It's not necessary to turn that off. That's just how you turn it off if you want to. So over here, if you single click a file, you open it, and it gets temporarily opened over here on the right-hand side. So if I open tronbattle.cpp, this is tronbattle.cpp. Over on the right-hand side, it's been temporarily opened, but if I double-click it, it adds it to the tab of all the files over here. Okay, and that's the file that I have opened. Now, let's say that I want to add a file to my project. So let's say, for example, I didn't have tronbattle or tronbattle.h or tronbattle.cpp in my project, but I wanted to add them there. So I'm going to just remove them from the project. And now what you might think you would want to do is go to File, New, File, and then add a file, right? Or go to New Project or New whatever. Don't do that, because Visual Studio is a bit annoying in, like, if I go New File now, it's going to save that in like my user's local app data Visual Studio folder, who God knows where that's actually going to end up, okay? So what I do when I want to add a new file, so I'm going to come over here to my actual, and I know this is small, so I apologize. I've got a bunch of files here in my directory. Actually, this Tron level isn't supposed to be there, so I'll delete that later. So I can see here that in my source directory, I've got all of the files that are in the project. Now I want to add tronbattle.c and tronbattle.cpp and tronbattle.h to that project. So if you want to add like a new file to your project, I would say like new text document, like my class.h, create it there inside the source directory. And then over here, you right-click the project, add existing item. And then this will come up, and then you can add those items. So let's say I want to add myclass.h, tronbattle.h, and tronbattle.cpp. I can control-click those and then add them to the project. And then you can see they're back over here in the project file, okay? Now, myclass.h, I don't actually want that, so I'll remove it. Okay, so that's how you would add something to the project in sort of the proper way, okay, with this project that I've given you. So if you ever want to like make a new project, please don't make new projects and submit them to me. They're going to have all sorts of options that are completely wrong. Only ever edit the project files that I give you, please. If you need to add a new file, you won't for any of the assignments, but if you do for the project, that is how you would do that. Okay. So I've explained the difference between a solution. So solutions only contain projects, okay? Projects contain the files, and that's how that works. So now what we can do is look at some of the properties of a project file and a solution file. So let's look at the properties of a solution file. Very, very infrequently will you ever have to edit the properties of the solution file, okay? You can put things in here like configuration options like release or debug or what platform you're compiling on, but these are going to remain constant for all of our assignments, so we're not going to look at those right now. I've never actually edited any solution file properties in my life. I've only ever edited project files. So if we look over at A1 Tron, that is the project file, now we can open up the project settings and we can just have a look at some of those, okay? So in here is where a bunch of the options for the project, well, all the options for the project are actually listed. So some of the important things here are that all of these paths that you see, they are relative to where the project file lives on your hard drive, okay? So here, for example, I've said that the output directory, so that means the output directory for my compiled executable program, the exe file, is in /bin/. So this is obviously relative. It means go up one directory and put it in bin. And the reason I can do that is because in my assignment, the Visual Studio file is in the Visual Studio folder, right? So if I go up one directory, there's the bin folder, and there is where my compiled project is going to be. So let's just compile the project real quick, and we'll show you that. And I can do that in several different ways. I can right-click the project and click Build, and that will build the project. Okay, so down here, this is a little bit tough to see because of the font size, but it has compiled every CPP file and then linked them together and then said, okay, here is in the bin folder, there's a1_tron_d.exe. So if I go back there to that folder, okay, just want to make sure I don't look at anyone else's files. Now in my bin folder, there are a few more files. One of them is the executable file, and then there's some PDB and ILK. These are like intermediate output files that Visual Studio needs for debugging and stuff like that. Those, don't worry about those. They're not part of your actual assignment. But the executable file that it produced, a1tron_d. So if I double click that, the assignment runs. Okay, and this is the assignment. It is Tron. I'll explain the rules of Tron in a little bit. I just wanted to show you where that file went. So that's one way of doing it. You can right-click, build, and then go to the directory and run it. But an easier way of doing that in Visual Studio is to, up here, we can see these three options. There's two that are really important. One is the configurations. One is debug. One is release. So we're currently in debug. I'll leave it there. Debug is, it runs a lot slower, but it allows you to use the visual debugger, which I'll show later. Release runs a lot faster, but you can't use the debugger in the same way. So we'll leave it on debug for now. And then whichever one we select, we just hit local Windows debugger. If it's not compiled, it will compile it. And if it is compiled, it will run it, okay? So here we're running it. I can press the R key to reset the Tron file, etc. But you can compile and run in one easy step just by hitting that button, okay? So that's probably what you'll do if you're using Visual Studio. Now, over here, while the program is running, you get really cool diagnostics. You can see how much memory is being used, the CPU percentage, different events that have handled. Like, this is the reason I still use Visual Studio, and I still use Windows, because the debugging tools are just incredible in Visual Studio. Okay. There's one more thing that I want to go over, and if you are reading the installation instructions, actually, let me go back here. I'll go to my website, teaching, go to assignments, and then environment setup. Okay, so let me go through this one time with you, even though it's very, very easy to set up and run this. I want to go over the Windows instructions to set up these assignments, okay? I'll go over them very quickly, but they're here and they're detailed for you if you want to. You will go through them yourself. So first, you have to download and install Microsoft Visual Studio 2019. That is the Visual Studio version we're using. You download the 32-bit version of SFML. So whatever you Google SFML, you go to the website, you download the 32-bit version of that. You extract it to a folder on your computer that has no spaces. I highly recommend no spaces because sometimes having spaces in library file names can be a bit weird. What I do is I have a folder which is C:/libraries and extract SFML to there. So any libraries I have on my computer are in my C libraries file, and I just extract it to, like, this is where I have it. You don't have to have it there, but that's where I have it, okay? Now, what we're going to do after that, because Windows is a little bit annoying, is we create a Windows environment variable that's going to be used by Visual Studio to point to the SFML include directory. Okay, so in order to do that, you click the Start menu, you type env, you click Edit the environment variable, you click New, you click Create, and then you're going to do this. So if I click my Start menu and type env, it says Edit environment variables. I get this window, which is super, super small, but essentially what you have here after you've completed this process is a directory called SFML-dir, okay, and that SFML-dir is C libraries SFML-2.5.1. You can either put it in the variables for only your user, or you can put it in for all users. I usually put it in for all users. So that is going to let Visual Studio know where SFML is installed. This step may not work if there's any spaces in it. Yay, Windows. All of these lab instructions, you can ignore them because we're not using the lab this year, obviously. If you had Visual Studio open, you have to restart it now because Visual Studio reads in the environment variables when it starts rather than when it's it doesn't reload while it's running. Then you can go open up the solution file. So that's where we are right now. And the rest of the instructions are just how to compile and run, which we've just gone over. But if I look over here, the way that Visual Studio knows where the SFML library is over here in the project settings. If I click C++ directories, here it says $brackets SFML-dir/include. So this $SFML-dir, that is an environment variable, and that's how you call it from within Visual Studio. Okay, that's the syntax for that. So what I've done here is made it so that you don't need to go manually add your Visual Studio, your SFML directory to the Visual Studio project. That's already done for you, but it's done via this environment variable. Okay, so what you have to do is set up the environment variable so that Windows knows where your SFML-dir is. So that's why I've done it this way. It makes it much easier on the marker. It makes it much easier on you. You just set up that environment variable once, and then all your project files will work. And so that's where it knows all the header files are for SFML. So that's the include directory, and also all the lib files, which are the precompiled binaries for SFML. Okay. Then there is all sorts of stuff for like C++. Like for example, we're using C++ 17. So here is where you can change all of those options. We're building an application. We're using the latest Windows SDK. We're using Visual Studio 2019. All that kind of stuff is all set up for you in the Visual Studio properties. So that's how Visual Studio knows where SFML is, and you only have to set up that environment variable once. If we want to edit some of the C++ compilation options, so for example, we have like optimizations turned on, we might have debugging options turned on, all of these are here in the project set. Okay, so you don't need to edit any of those project settings, but if you're interested in it, that's how Visual Studio does it. Most of those things, if you're using Linux, would either be set up in the make file. If you're using Mac, maybe you're using Xcode. I'll just warn you now, if you are using Xcode, I cannot help you. I've never used Xcode, so I don't know how to help you with that. Okay, someone in the chat asked, in 4300, I followed the SFML tutorial and put my directory in the C++ and linker can we no longer do that? So yes, for example, instead of putting instead of using this, you could hard code the directories there if you want, or you could put them in the additional include directories, or in the linker, you could put them in the linker options. But don't do that. That's just a roundabout way of doing it, okay? Please do not do that. It's already set up for you. Just set up the environment variable and it's all done for you, okay? All right. Someone else asked, are we supposed to test our code against the release configuration, or configuration won't matter? I'll get into that in a bit. So now we're going to get into compiling and running your program. We already looked at this a little bit, but right now, if I look at the properties, and I have right here, there's an option as set as startup project. So if I had multiple projects in my solution, then I would have to set one of them as the startup project. By default, if I only have one project, it is the startup project. And so the startup project will be run whenever I click Run Windows Debugger, okay? And what will happen is all of these files will be compiled and linked together, and then the main function, wherever it finds the main function, that will be run. And I'll be going over how the whole assignment works, but I'm just going over Visual Studio stuff now. So whenever you click this, it will run the main function that's included in your project somewhere. Okay, if for some reason I wanted to wipe out all the things that I'd compiled and completely recompile from scratch, you can click Clean. And so Clean will wipe out all the intermediary files and object files and recompile them. Well, it'll recompile them when you click Build again. So here you can see it had to build everything. If I click Build again, it says, hey, everything is already up to date, so I don't need to do anything, okay? If I switch over to release mode, everything is the same, except the executable that it produces will not have that _D. It will just be A1tron, all right? Someone just asked in the chat, is this an AI course or a VS course, Kappa? I know I'm taking the 40 minutes to explain all of this now because I didn't do it in the last course and I had a lot of individual emails about Visual Studio. So since the course is officially being given with Visual Studio, that's why I'm doing it. We'll get into the AI, I promise. All right, so compiling the release version gives you aitron.exe. Compiling the debug version gives you aitron_d.exe. And you may ask yourself, why is that? Why does it name it differently? Well, if I right-click the folder and I go to General, over here, the target name inside bin is project name. So what that means is the target executable file, the output file, under release, okay, whenever I'm compiling in release, the project name .exe will be what is output. If I switch over to debug, then you can see here, I've put project name _D as the output file. So that's how it knows how to produce like _D or whatever. Okay. Another comment, it speaks more about the software than your content. I understand that, but I think that Visual Studio is one of these pieces of software that is incredibly powerful, but not immediately user-friendly. And as programmers, you will run into many things like that. And so it doesn't make it a bad piece of software. It's a very powerful piece of software. And if you know how to use it, and you've gone through it and you've used it a little bit, it will make your software better, in my opinion. Okay. So let's go through. Oh, one other thing here is that you see here in the bin folder, we don't only have just the executable files. We have like iobj, pdb, all these are for debugging and for Visual Studio. So you don't need to keep those there, but you don't need to delete them either, okay? When you submit your code to me, for this assignment, you are just going to be submitting the tronai.cpp file. No other file. So anything that's produced by Visual Studio, any executable file, anything, You're not even submitting to me, so don't worry about that. But one thing that is important in your Visual Studio life is that over here, what I've done, whenever Visual Studio compiles something, there are a lot of intermediary object files. So for example, it will compile every CPP file into an object file, and then the linker will link all those together. And so over here is the intermediary directory. So the intermediate directory. The intermediate directory is where it places all of those object files and all of the temporary files that Visual Studio needs to operate properly, okay? So here, I've called that configuration. And what that means is, up here, release is the configuration. If we're in debug mode, then debug is the configuration. And these directory names are relative to the Visual Studio file. So if I go into the Visual Studio directory where my project file is, then you'll see two directories. You'll see debug and you'll see release. So since we've compiled in debug, okay, you'll see all of these intermediary files in here. Since we've compiled in release mode, you'll see all the intermediate files there as well. You can completely ignore those files. And one thing is, if you ever, for any reason, want to zip up and send the whole directory to your partner or something, please remove these files, because our entire assignment is 33 kilobytes, but the intermediate output files are 330 megabytes. Okay? So these files are very, very large, but they have nothing to do with the final project executable, which is just 45 kilobytes. Okay? So I'm just showing you where those files live. Okay. Now, I think I've pretty sufficiently explained Visual Studio and what you need to know for actually... Oh, one last thing. If I go to Properties and if I go to Debugging, okay, right here, this is an important variable. This is the working directory variable. So whenever you run a program, you are running that program from a specific directory as the working directory. So if you specify a file name, for example, if I want to load config.txt, which I actually do, let me go here. So if I specify config.txt, in what folder on my computer is it looking for config.txt? Okay? Well, it turns out that it is looking for it inside the working directory, and that working directory is set here in the working directory variable. So this is the project directory. Go up one directory and go into bin. So that means whenever I'm running my program from Visual Studio, it is using the bin folder as the working directory. So if I run the program, it's going to be reading config.txt from the bin directory where I want it to, because that's where I've set the working directory. Now, if I've set that working directory to something else, right, I can set it to literally whatever folder that I want. But then if I come over here and I just double click my executable file, so in Windows, whenever you double click an executable file, the working directory by default is the directory that the executable is in. Okay? So just make sure that you know that this working directory is for when you hit local Windows debugger and run it from Visual Studio. If you double click the executable file, then it will use the directory that the executable file runs in as the current working directory. All right. Now you don't need to change any of that for anything in this course, or for this assignment especially, but just to let you know, that's how that works. Okay. So that's enough about Visual Studio's options and stuff. Now I'm going to go over the structure of the files for the assignment, and then I'm going to run things, and I'm going to show you, after we've explained the assignment, I can show you the debugger a little bit more, because it makes no sense to really use the debugger until I've told you what the files are, right? So first things first, to make things confusing, I'm going to go over to Visual Studio Code to read the text files, all right? Because it has this nice directory structure, and it's also a nice text editor. Okay, so this is Visual Studio Code. I'm only using it as a glorified notepad, okay? Visual Studio Code is not Visual Studio. Remember that. Okay. So this font size should be adequate. There we go. And let me make it a little bit bigger. Okay. Now we can, this is assignment 1. So we're doing this live, okay? I actually might need to edit this text file a little bit, but we'll see. So here is the text file, the readme.txt that you should read when you go to start assignment 1. This will explain what to do. For this assignment, you will submit only one file, source/tronai.cpp, as you should only be modifying this file for this assignment. If you submit any additional files, this will result in a loss of marks. Please do not submit a zip file containing that file, just the file itself. So, you might think that I'm being pedantic here, but computer science and programming is literally all about pedantics and syntax, okay? The compiler is going to be pedantic. Your boss is going to be pedantic. Your paycheck is relying on you being pedantic and syntactically correct. If you submit anything other than just this file to D2L, it's minus 10% on the assignment. That's just how it is, okay? So please pay attention to that, because we have a script that automatically extracts all the files and does everything. So that's very important for the marking process, is that you only submit tronai.cpp. So you will just upload that to D2L, nothing else. Don't zip it. Don't have the .macosx folder that I always see. Don't submit the whole source folder, just tronai.cpp for this one. You must include the following in a comment at the top of the file. All students' full names, CS usernames, and student numbers. As you can see by what I had there before, I have included your information as part of it, but please, you're only submitting one CPP file per group, and in this course, assignments can be done in groups of up to 2. So, what you do, whoever happens to be submitting the file, it can be either of you, but please don't be both of you, take this, delete it, and enter in the name, username, and the student ID of the other person in the group, okay? And then submit the Tron GUI. So you would be using, Tron GUI, Tron AI. So you would be altering this file, then editing the code, and then doing that. Okie doke. So let's go back to the text file. If you did not get a specific feature to work, please explain what you tried to do to get it to work, and partial marks may be given for effort. Now, assignment 1 is very, very simple, so you probably won't do that for assignment 1. Okay. Program specification. In this assignment, you will be writing an AI for the game of Tron. If you don't know what Tron is, let me run it real quick. So if I go back to Visual Studio, Tron is a game in which there are these light cycles, and these light cycles can turn, so they go straight, and they can turn left or right, basically. Okay, so you can go straight, left, or right. Let me restart this. You are going to be writing an AI to control the direction that your Tron light cycle, they're all called light cycles because in the movie Tron, they're driving motorcycles. And the rules of Tron are, you keep going until you either hit a wall or you hit an enemy. And when you hit an enemy, you die, okay? So in Tron here, I've included 3 example AIs, which I'll go over for you. Here you see group name. That's going to be your AI. It just goes straight until it hits a wall. So it does literally nothing. Random will choose a random direction. So over here, this is color coded. So this random AI is this yellow one down here. And at every time step, it will just choose a random legal direction to turn into. By legal direction, I mean that you can't turn backwards. Okay, you can't go back on yourself. So there's always 3 options. Go straight, left, or right. Or up, down, left, or right in our case. I've got a random safe AI. So random safe will, if it's about to head into something, it will go in a random direction. Okay, so it will choose a random direction unless that random direction would immediately hit something. So you can see here that usually random safe has better performance than random because it tries to do something a little more clever. And then go straight, you see go straight is usually winning. Go straight literally goes straight until it's about to hit something and then turns a random direction, okay? So that's what you see here. And you can see that go straight until you're about to hit something usually beats random. And that's pretty intuitive, right? Like, because it's covering more of the screen. Okay, and I'll go into the details of those, but the whole point here is to get the highest score. And so the score here for go straight is 304, random safe was 18, random was 18. And after everything is submitted for this assignment, we will be having an in-class competition live on the stream, okay? So at some point after the marking is done, one of the lectures will run the competition. And something I'm doing differently this year is that your maximum grade for this assignment is 95%, unless you're in the top 8 of the competition, and then you can get 100, okay? So I just want to see how that goes. Because there's not much of an incentive to try and do really well unless your performance is somehow tied to your grade, right? So you can get a 95% in this assignment by doing all the required things, which we'll talk about, but you can only get 100 by coming in the top 8. All right, so let's try that out this year and see how that goes. Okay, so let's go back to the text file now. That's Tron. You're writing an AI to play Tron. Your function will return an unsigned integer or a size type in C++. So wherever you see size t, that's just an unsigned integer, corresponding to the index of the action to be taken in the m directions vector defined in tron battle.h. And we'll go over that. But essentially, at any point in the Tron game that I've released, you can go up, down, left, or right, okay? And so that is defined by a direction structure, and that direction structure just contains an x component and a y component. So the 0 is the x, and the other one is the y. Now let me open up this one more time. One important thing to note is that in SFML and in our assignment, 0, 0 is going to start in the top left, okay? So that means x increases to the right. So this is x0 right here. This is x equal to 10, x equal to 20, x equal to 30, x equal to 40, etc., etc. And y increases going downward. So unlike your typical Euclidean plane mathematics where 0, 0 is in the bottom left and y increases going up, for SFML and for most graphics libraries, 0, 0 is in the top right and y is going to increase going downward, okay? So if we look at, here I've told you what the directions are. So up would be 0 in the x direction and -1 in the y direction. Down would be 0 in the x direction and 1 in the y direction. Left is -1 in the x direction, 0 in the y direction. And right is 1 in the x direction and 0 in the y direction. And so actions, okay, the action that you're returning from your function that you're going to write for this assignment is the index of which of these directions you want to go in. So if you want to go down for the next time step, you'll return 1. If you want to go left, you'll return 2. If you return 3, you'll go right, etc., etc. So that whenever you see an action or an action index in the code, it refers to this. Okay? It's the index of that vector which contains these directions. So directions are stored as a struct with an x and a y variable denoting the change in x and y, if that direction is chosen to move. For example, moving right is a shift of 1 in the x direction and 0 in the y direction. So the resulting direction is 1, 0. In this environment, y increases in the downward direction, so the down direction will be 0, 1. Example usage of direction can be seen in the example AIs in tron.cpp, which I will be going forward. So the controls for the game, the R key restarts the level, and the escape key exits the game. So after the level has been completed, so after everyone is dead, if you hit R, it restarts it with a new random seed. Okay, so that's just hitting R over and over and over again will restart it, and hitting escape will stop the game. So those are the very basic controls that you have control over. there is a configuration file, which I've changed a little bit and forgot to update this. So if I go over here into the bin directory, there is a config.txt. And what you see, the first line is the width and the height of the Tron board. So that gets read in by me and it does everything. Oh yeah, I forgot to mention, all of this user interface is already done for you. Okay, so I've written all of that. All you have to do is write the AI. And so this Tron board is currently, if I go back over here, it has the following options. So it is 64 cells wide and 36 cells deep, or sorry, high. The size of the cells that are being drawn doesn't matter at all, okay? You can just think of this as a 2D array. The size of the cells is only used for drawing it to the screen, and I'll show you where that is later. So if while you're writing this, it's either too big or too small, you can change that if you want to. Now, there are 4 other lines here. There could be any number of lines, but these define the AIs that will be used in the running of this particular Tron battle, okay? So this Tron battle here has a player student, it has a player random safe, and a player go straight. And so these strings here represent the AIs that will be running. Then there's a few extra variables over here, and the variables are the X, Y starting location. So player student starts at 3, 3. So this is 0, 0 in the top left. And if I go down 3, 3, that was the starting location of that player, which was student. Then there's player random, which is yellow. So that starts at 60 in the X direction and 32 in the Y direction to come down here. And that was yellow. So for example, if I change this to be 255, 255, 255, which is RGB white, and then I run it again, then that player should be white, right? So that defines the color and the starting position of the player. And if I go back and if I change the starting position to like 16, or let's say 30 and 16, then that's somewhere in the middle-ish of the level. So that player should start in the middle, okay? So that's what the config file is. And not only that, but we can actually go through, and if we want to like completely remove one player, we can do that, and we'll run it again. Okay, so that's how you define how many players there are. All right. So let's keep going through the README. So here you just get the specification for that, okay? So this is the actual specification for the config file. So we just went over that. I don't need to go over it again. Except for the string of the name of the AI is hard-coded in Tron AI, and I'll show you how that works, okay? So some marking notes. Marking will be pretty lenient for this assignment. You must do something significantly different than the examples, okay? So I don't want you just handing in another random one. You must do something that has significantly different behavior than the examples that I've given. And it says you will get a max of 95% in this assignment unless you rank 8th place or higher in the in-class competition. I just had a question about the competition. Will there be a tournament style, i.e. last one standing, or does everyone play one round and rankings are in order of score? I'll probably be playing pools with a top 16 or something like that, okay? So there will probably be pools. We'll see how that runs. I'm not going to give out the exact scheme just yet. But I will try and make it fair so that, for example, maybe if we play in groups of 4 and the top 2 go on, maybe the 3rd place there was actually like the 7th place overall but got eliminated early. So I'll try and make it so that the random pairings don't matter in the overall result. Maybe we'll do a bunch of 1v1s or a round robin or something like that. We'll see. Okay. But I forgot to mention this over here, but in order to get full marks, you must beat the sample AIs most of the time. Okay, so if we run your solution and it doesn't beat the sample AIs, then something is wrong. Okay, I want you to do this. I want you to think about it, and I want you to beat the sample AIs most of the time. Now, for this assignment, and this assignment only, if you want to, during the development process, you can say trade AIs with other people in class just to see, like, okay, not to like copy from them, but just to do some battles. All right? This assignment only, and only share your tronai.cpp file and make sure it doesn't get online, okay? But if you really want to like see how you're doing against other people, if you have some friends in the class, you can do that just for this assignment, okay? But do not copy what they did. That's very important. But I know it's probably going to be fun to like play against your friends and stuff over the next 2 weeks. So that's what I want to happen there. And that's it for the README file. Okay, so now let's go over the structure of the assignment and how it actually works. So this assignment, as I said before, so let me go back here. We go MUN 4303. Okay. So you have 2 weeks to do this assignment, okay? This assignment is, I haven't taught you anything yet, right? So you're not necessarily going to be using anything that I've taught you in the course to do this except C++ stuff. You can use stuff that we teach in future lectures, but essentially I want you to take the next 2 weeks to use this to get used to C++, to get used to the Visual Studio project if you're using Windows, to get used to the Makefile, and just get used to C++ overall. Okay, so that's what this is for. Now let's go over how this assignment actually works for the C++ side of things, for the SFML side of things. Okay, so the first place to look is always the main file, right? So, oh wow, the main file for this assignment is super short. Now I'm probably going to go over in this lecture by about 10 or 15 minutes, but that's fine. Because I won't need to explain Visual Studio in the future, right? So what you see in the main file here is pretty simple. I set up this Tron GUI object, and that's going to be called G. I could also call that GUI if I wanted to, right? That's going to be constructed based on the config that I've passed in, and then we're just going to run it. So when I release code, I like it to be really modular and use classes in a proper way. So really nice object-oriented programming. I have a GUI and I click run. All right. So let's have a look at the GUI and see how the GUI works. So here is the GUI's header file. So whenever you're looking at new C++ code and you want to see how something works, you should first look at the header file, because the header file will have the structure, the overall structure of the class, and you can get a lot of the functionality out of that. So the header file will show you the overarching architecture of a file, and then the CPP file will show you the implementation and the code that actually makes it run. Okay? So if you're coming from Java, then that might be a little bit different, or from Python where all the code is just there. But this is one of the nice things about having header files separate from CPP files. So let's look at the variables in the GUI file. So the GUI has, let me run it. So I'll have it up on the screen so we can actually look at this while it's running. Okay. So in Tron GUI, I have this. Okay, so we'll put it right under here. So I've got standard string path. So that path, I believe, it stores the path to the config file. Okay, so if we want to reread the config file to restart the game, that string right there, path, is going to store that. Next, we have a Tron battle class or object, and that's called m_battle. And remember, the m_ means this is a private member variable of that class. So the Tron battle is going to do all the logic of the Tron game. So that contains the rules of Tron itself, and like how the game is run, how it handles the light cycles, how it handles the AI. All of that is handled in Tron battle, and we'll have a look at that next. Because the Tron GUI only handles the user interface, okay? So the user interface is completely separate from the logic of the game, and I really like that architecture. So actually, first, let me go back to the config file, and I'm going to edit this to be what it was at the beginning. And then I'll close this down. I will rerun it because I want it to show, I want it to look like how it's going to look like for you. Okay, so I re-edited the text file. Okay, so next we have the render window. So this is part of the SFML library. And the render window is the actual window that I'm dragging around right now. So everything needs to be drawn to a window. And so this mWindow variable is an SFML render window, and that's what everything's going to be drawn to. So in order to use SF render window, I've actually got to include sfml/graphics.hpp. That contains all of the graphics calls for SFML. I've also included audio.hpp here, but this assignment doesn't use audio, so I could probably remove that. Next is a font. So in order to draw text to the screen, what you have to do is you have to have a text object. So there's two variables related to drawing text to the screen. One of them is an SF text object. That object is going to store the actual string that we want to draw. It's going to store the size of the string that we want to draw, and it's going to store a pointer to the font that we want to use to draw it. So we've got an SF text that stores the string. It also stores the position of where we want to draw it on the screen, and it also stores the font itself. Next down here, we've got a float, which is the grid size. So right now this is set to 16. If I change grid size, let's say to 24, then what I'll see here is when I rerun things that the game got a lot bigger. So the grid size is the actual size of each of the cells' width and height because they're all squares, okay? So I'm going to set that back to 16. All right, so that's 16. So if you are running this and it's either too big or too small for your screen, depending on your resolution, you can change that variable to make it whatever size that you want. And that will not alter the number of grid cells. It will just change the size of the display. Next, we have a Boolean, which is whether or not the game is actually running. And that's just used to draw the stuff to the screen or close the program. So if I hit escape, running gets set to false and the window closes. Next, we have some functions. Set map, that just reads in the text file and sets up the 2D array. That is the, actually, I'll show you what that is. There's an init function. There's a user input function that handles the key presses of the escape key and the R key. There's a render function. The render function actually draws things to the screen. The draw line function, SFML doesn't come with a line drawing function, believe it or not. And so that is, it takes in x1, y1, and x2, y2, and a color and draws a line, and I use that for drawing the grid cells. And I also have functions to determine the battle width and the battle height in terms of pixels for drawing things on the screen. Excuse me. And so then I have the constructor for cron GUI, which takes in a string, which is the config file, and then just run, which runs the game. So let's have a look at how the game is actually run. So this is the trongui.cpp. So this is the implementation file where you actually see the code that makes it run. So up here, you have the constructor. So the constructor takes in the string. I set the path equal to that path. So that like just stores the variable for the config file so I can read it again later. I have this called set map. It should actually probably be set battle. And it sets the current battle equal to a new Tron battle object with the path as the constructor, or as the argument for the constructor. And we'll go into Tron battle in a little bit. Then there's an initialization function. So the initialization function, it sets up the window that we're going to draw things to. So this is all SFML code, which you don't really need to know, but you know, it doesn't hurt. Then it sets the frame limit of SFML. So the way this works is that if I set the frame limit to 10, this is the maximum frames per second that the game can run. So if I set this to 10 and then I run it again, that you'll see the game is actually going much slower, okay? So if you want to slow down the game so you can see what's happening in more detail, you can edit this set frame limit variable. So I have a 144 hertz monitor, so if I set this to 144, this should be a lot faster. Okay, yeah, so that's a lot faster than it was. But this is the maximum number of frames per second, and I believe by default VSync is on. So yeah, so you can see this is running about half the speed of 144. So just leave it at 60 until you want to change it. Here is where I set up the font and I set up the text, okay? So in order to set up a font, inside my bin directory, which is the working directory of the assignment, I have a fonts folder, and I just have this font that I downloaded for free. It's called Tech, and it's a really small font. It's like 30 kilobytes or something like that. And so if I had like Arial or Times New Roman, though, this stuff over here would be drawn using that font. Here I set the font for the text. So this m_text object, that's what's going to store the string and the positions, and it's also going to store a pointer to that font. And then I set the character size. So here, if I set my character size to 40 and then rerun the program, then my text over on the right will be much bigger, right? But I don't want that. Okay. Now, the next function, so that's the initialization function. That just sets everything up. Here I have the run function. So the run function is what's called by the main, and let's just see what happens there. So while running, so while the program is running, I'm going to tell the battle to do a turn, okay? So every turn is one movement, and so every frame, so if I have this set to 60 frames per second, every frame, it's going to update the battle. And so it's going to call the AI once and then update the positions. Then we're going to handle the user input and render the scene. Here I just have a line drawing function. That's not very important. Here I'll briefly go over the user input. So the way SFML does user input is through an event system. And so we get this event object. We tell the window to pull its events into that event object, and then we loop through it with while. And so what this does is it just handles certain types of events. So we're not going to go in detail in this. If you want to learn in detail about events and stuff like that, type exclamation point playlist in the chat and go to my 4300 lectures. But it just says, hey, if you've closed the window, the game is no longer running. Also, if we've pressed a key, well, do a switch statement on the key code. If we've pressed the escape key, just set running equal to false. And if running is equal to false, then the program will terminate. And if I hit the R key, it does set map, and set map restarts the battle. Okay? So if I hit the R key, it restarts the battle. And by restarting the battle, everything resets. Okay? That's how that works. So that's the user input side of things. Then I just have some helper functions to determine the battle width, which is just the grid size times the width. Next is the rendering. And the rendering for this is really simple. First, what I do is I just clear the window. And if you call clear with no arguments, the argument here is the color. So I could clear the color to like a gray or something like that, but with no argument, it just clears the background to black. Here it says draw the background, but this is just a grid size that I'm going to use to draw some things. This is a rectangle shape from SFML that I'm going to use to draw. So here I've set that up equal to the grid size. And so I've got this rectangle, which is the size of the grid size, and I'm going to draw that rectangle if something is colored properly. So then I go over, for each tile in the battle, I use battle.getTile, and this value, how are the values stored? Well, let me show you that. So each of the players, or each of the cycles for this assignment, have a unique identifier. So based on the order in which it was added to the game, so here, the unique ID for this group name, okay, so for a group name, this is going to have ID 0. Random is going to have ID 1, random safe is going to have ID 2, and go straight is going to have ID 3. So the way the battle works is whenever we add a new AI or a new cycle, it just gets, it starts from 0 and goes up by 1 for its ID. And then the way that this battle or this array or grid works is that initially, behind the scenes, this is a two-dimensional vector or a two-dimensional array, and it holds all negative ones. So everything is negative 1, okay? And then when a cycle moves inside the array, it sets the value of the array equal to its unique identifier. All right, so that means that as this cycle moves along, okay, it is setting, or the green one moves along, it's setting these values, so every green cell that you see here has a value of 3 in the underlying array. So that's the data structure. And that's important because you can say battle.getTile xy, and that is how you know which Tron cycle has actually visited that tile. Okay, so if battle.getTile is equal to -1, then it's a free tile. If it's anything but -1, then it's equal to the ID of the cycle who has visited that tile. So here, this is the render function, remember? So this is how I'm drawing things. So this just says, hey, if the value is equal to -1, then I don't need to draw anything there. So I just continue. Otherwise, if it's not -1, then what I do is that value, that's the unique identifier of the Tron cycle. So I set the fill color equal to the cycle's color, and we'll talk about how that works. Then I set the position on the screen where I want to draw the rectangle, and then I draw the rectangle. It's that easy. Then after I've drawn the rectangles, I draw the grid lines, and then after that, I draw the score. Okay? So for each player, I just get their name, and I set the string, and I set the position, and I draw it. And that's it. And then down here, you call display, which refreshes the display of the window and waits until 16 milliseconds are up so that it can run at 60 frames per second. So you can see just how easy SFML is, right? That's why we're using it for the course, because it's so simple to use. Okay. So we've talked about Tron cycles. I want to show you how those actually work next. So this is the Tron circle header file. Oh, I had a question. Is there any benefit to have a faster AI, or does the game wait for each AI to make a decision? Is there a time limit on decision making? Good. That's a very good question. I'm going to put a time limit on decision making for the assignment of 100 milliseconds. Okay? So you've got to be able to go 10 frames per second. Because I don't want these battles to take forever. But you are right that the game will wait for the AI to finish no matter. So if your AI takes 2 minutes to run, it will wait the 2 minutes before it does the next drawing. Okay? So I'll put that in the README file for the assignment, but let's just say that your code has to run in 100 milliseconds. Okay? Just to make it fast enough to actually run. Okay. Good question though. So here is the Tron cycle structure. So this is the class Tron cycle. Here are the variables for a Tron cycle. So there's an ID. This is a unique integer identifier. So each new Tron cycle gets unique ID 0, 1, 2, 3, 4. And again, I know that this lecture is going long. It's because we had to explain Visual Studio. We've got about 15 minutes left, but because it's asynchronous, that doesn't really matter. We've got the X and Y position. This is the X and Y position of the Tron cycle on the grid currently, right? Because it's got a... so the cycle doesn't contain all the places it has been. Those are stored in the grid. But it does contain where the head currently is, okay? Because you need to know where the head of the Tron cycle is, or the current position of the light cycle, in order to make AI decisions. It's got the current direction that the Tron cycle is heading. So for example, if this direction is 0, it goes by whatever it was in the README file. So if I go back in the README right here, 0 is up, 1 is down, 2 is left, 3 is right. That is what's stored in this mdir variable. That is the current direction that the Tron light cycle is heading. And if that direction is not changed, then it will continue going up or continue going right until it is changed. It's got the color variable. That's the color that's being drawn to the screen. It's got the current score. The score goes up by 1 every time step until it's dead. And it's got whether or not it's currently alive, and that starts as true and is set to false when it dies. We've also got a little kill variable here, which the battle uses in order to kill it. And then we've got some getters for each of these variables, okay? So that's pretty easy. Up here, you see an interesting thing is that all of these variables are private member variables, so they can't be changed by anything outside, but we do want the Tron battle to be able to modify the light cycles, because the Tron battle is sort of our game class, and so we want our game to be able to modify the light cycles. And so in C++, you can set friend class Tron battle, and that will let any code within the Tron battle class modify the private variables of the cycle class. So this is just nice, rather than making these all public and making them modifiable by other AIs and stuff, only the Tron battle is allowed to modify the light cycle variables. That's what that says. Okie doke. And inside the CPP, that's just how you implement all those. It's really boring, so I'm not going to go into that. Next, I have the Tron battle itself. So let's look at the Tron battle. So the Tron battle is like the game engine for the Tron game. And you kind of want to know how this works so you can write your AI properly. So it has to store the width and the height of the battle, obviously. It also stores this level here. This probably, maybe it should be called map or level or whatever. That's the actual grid of values that it's going to store for the Tron battle, okay? So this is a vector of ints. You're fourth year students. You should know how a 2D array works by this point. It's also got a standard vector of shared pointers to Tron AIs. I'll explain what that is in a second, but just think a shared pointer to a Tron AI, that's just essentially a pointer, okay? But our Tron AI class it has a base class and derived classes. And so in order to store a base class pointer, it has to be a pointer in C++. That's a little bit different than Java. If you want to know more details about that or you're confused, you can watch the lecture that I said for you to watch if you're unfamiliar with C++ on Computer Science 4300, where I go into memory and pointers, okay? So if you are confused about this line of code and what a shared pointer is, go watch lecture 3 of Computer Science 4300. It's also got a vector of cycles, and those are the actual objects that are, the cycles themselves. It then has all of the directions that we talked about in the README file, and those are the directions that you can go in the game. Okay. And so all the rest of this is essentially just bookkeeping for the battle itself, and two functions that you have to be concerned, or there's a few functions that you have to be concerned with. So you can get the width and the height of the battle. You can also ask, is this a legal action? So a legal action in Tron, hang on a second. I'm going to go use one of my scenes that I haven't used yet. 1 second. Edit. Oh, you're getting some behind the scenes action here. Blackboard. It works. Sweet. Okay. So here, I'm going to really, geez, it's a terrible color. Okay. So pretend this is a grid and it's not like a mangled mess. Okay. Perfect. So let's say we've got, oh no, I don't want that to happen. That one's white. Okay. So I'm going to fill some of these. So this is like the red cycle. This is the blue cycle. We've got and a yellow cycle over here or something like that. So let's say that we are the yellow cycle. I do like flaunting my scenes. Thank you. So this is the XY. Oh, geez, come on, Dave. What are you doing here? Black. Okay. This is the XY location of the yellow cycle. Okay? Now, if the yellow cycle's direction, if it came from here, that means the direction currently of this cycle is equal to down, right? So the cycle came down from here, so the dir is equal to whatever the index is of the direction. So on the next index, I can set the next direction. I can keep it as down if I want to. I can go to the right if I want to, or I can go to the left if I want to. But I cannot set my direction to up. That is illegal. Okay, that is not a legal action because it would instantly kill myself and doesn't make any sense. So this function over here is legal action. You pass in a cycle and an action, and it will tell you if it's legal. So if I go back to the blackboard, here, going this way is legal, going down is legal, going left is legal, but going back up when I've just come down is not legal. There's another function there, which is safe. Is safe just tells you whether or not a particular grid cell is empty, okay? So it checks to see if it's a -1, essentially. So it'll ask, is this safe right here? Yes. Is this safe? Yes. Is this safe? No. If I run into that square, I die. Is this safe? No. Is this safe? No. So it's whether or not is safe is whether or not it's empty. Okay. So I've also put in a helper function there for you. So you can ask if a specific action is legal, or you can also say, hey, give me all the legal actions for this particular cycle. And if you do that, then you'll get a vector of all the actions that are legal, okay? And again, actions are indices, and the indices point into this direction vector. All right? Perfect. Do turn, that's just called by the GUI in order to do the turn. We'll go over how that works. Get cycles, that is a vector. So we've got, legal is not equal to safe. It's legal to run into something and die. Right? Eventually, you have to die in Tron. So it's legal to die, but it's not safe to die. All right. Here we've got get cycles. That will get you the vector of all cycles, which you might need to do if you want to look up the cycles and where they are, etc. in your AI. We've got get AI name. So that will get you the AI name of the particular cycle. That's stored somewhere. We've got get direction. So if we pass in the index of an action, this will return the direction that goes in, okay? Then we've got is safe. So is safe will return whether or not the tile is -1. Then we've also got get tile, which returns the actual value of the tile. So if you want to know if player 2 is on tile 6, 7, then if you call get tile 6, 7, it will return an integer, and if that's equal to 2, then player 2 is there. Is safe is just a helper function. You can accomplish the exact same thing with get tile by checking to see if get tile is equal to -1. Okay? So let's really quickly, we go through Tron Battle. Here is the initialization code for a Tron Battle. So it takes in the config file, and it just sets up all the players. We don't need to go in through that. Here is where we, if we want to get an AI name, we can get it from there. Here is legal action. It just basically computes whether or not we're trying to go back on ourselves, and if we are, then it's not legal. Get legal actions just sets up actually I should go through this. So here's how we iterate through all the actions. So the Tron Battle has a get num actions function. So this is the number of actions that you have. And then you can get the action by get direction, all right? So if I want to find out all the legal actions, I'm going to create a vector of those actions, and then I'm going to iterate for every legal action, okay? So for size t, action equals 0, action less than num actions, actions plus plus. If is legal action, cycle, action. So remember, I'm trying to get the legal actions of this cycle. So if this cycle, if it's legal to take this action, then I'm going to add that action to the vector of all legal actions, right? That's pretty easy. So that's what that function does. And then the do turn function is the last thing that I want to explain before we get into what you actually have to do for the assignment. So do turn is just going to go through, oops, I just hit the mic. It's going to go through every cycle. It's going to say whether or not it's alive. If it is alive, it's going to call its AI. Then it's going to do the move, and that's it. So for each cycle, let's get a reference to that cycle. So just so I don't have to keep calling this m cycles I. So if the cycle is not alive, then skip it because I don't need to do anything for that cycle. What I can do now is I'm going to say, what does the AI want to do for that cycle? So if I go back to Tron Battle, you can see here that there's two vectors, okay? There's the cycles vector and the AI vector. I have these in two separate vectors, but essentially the AI for AI0, so the 0th index, is the AI for cycle 0. AI's 1 is the AI for cycle 1, AI's 2 is the AI for cycle 2. Okay, that's how that works. So it says, oops, I just modified, did I? What the hell just happened? Why is this? Okay, so this is in red for some reason, but I assure you it works. I want to get the AI for a particular cycle. So if this is cycle I call AI I, and get the action from this battle and this cycle. And then I set the cycle's direction equal to that. Pretty easy, right? Then in order to update the position of the cycle, I'm going to get the directions and I'm going to access the direction of the cycle's direction. I'm going to add that direction to the position of the current cycle and then increase the score of the cycle. And then if the cycle is on a tile that's not safe, then I kill it. And then if the player is still alive, then I'm going to update the grid to have the color of that cycle. That's it. So that's how that works. And then there's some more helper functions. So let's close that. And now the last and most important thing for you is the Tron AI function, which you are going to write. So the Tron AI class is a base class, and then there are going to be derived classes that implement that functionality, okay? So every Tron AI is going to have a name. By default, it's default. We can get that name, and then each Tron AI has to have at least one function, which is the get action function. And this is the function you are going to be writing. So it takes in a battle, and it takes in a cycle, and then it wants you, the AI programmer, to return an action for that cycle in this phase of the battle. So whatever turn that battle is on. So we see here, we have a few different classes. So we have Tron Student, that's what you're going to write. We have Tron Random, that's the random AI, Random Safe AI, and the Go Straight AI. So let's go look over here at the different AIs. So what I've done for Tron Student is put some to-dos in here. So this is what you have to do for this assignment, okay? You have to replace group name with your group's last names, and then you have to write this function, which is get action. So all of your code for this assignment will go right here, whatever clever things you want to do. But you say, what's the syntax? How do I actually go ahead and like write that AI? Well, I've included those sample AIs here for you to do that. So let's go over the sample AIs, and then you can use that code as the starting point for how you want to write your AI. So here, for example, is the simplest AI, which is the get random, or the random action AI. So again, the get action function takes in the battle, and it takes in the cycle, okay? So if we want to get a random action, how do we do that? Well, that's really easy. First, we're going to get all of the legal actions for that cycle. So we take the cycle, we say, hey, battle, give me the legal actions for that cycle. And then that's the legal actions. Okay, so now we have a vector of integers representing the indices of the directions, which are the legal actions. Then, this actually should be random action index. So I'll change that. So we want to now, we have a vector of the legal actions, and I want to take a random one from that. So if I call the crand function, that gives me a random integer, and I use modulus or remainder with the size of the legal actions, this gives me a number in between 0 and legal actions.size minus 1. That's what that does. So that is the index into legal actions of the action that I want to select. And so I take the legal actions vector, index it by that random index, and that's how I get a random action. Really, really simple. I get a container of all the legal actions and I choose a random one from it. Okay? So, next we have the random safe function. So this gets a little bit more complicated, but your AI is going to be even more complicated, right? So random safe is going to choose a random action from the actions that are safe to do. A safe action is one that doesn't immediately kill you, okay? So we're going to set up a vector of safe actions, and then we are going to iterate through all the legal actions for the cycle. We are going to get the direction that we would go in for that action. So again, the direction is the structure with the X and the Y component. So the new X position of the cycle is going to be the cycle's X position plus the direction's X component, right? So if we want to move right, for example, 1, 0, that will be our direction. So in order to get our new X component, we take the cycle's X component and we add it to the direction's X component, which would be 1. So new X, new Y, that's the new position of the light cycle. And we say, hey, Battle, if that is a safe position to go to, then add that action to the safe actions. So now that we've done that and we've gone through all the legal actions, it's possible that there are no safe actions, right? And so we've got to do something if there's no safe actions, and so we're just going to keep going forward. So if you ever want to keep going forward, you just return the current direction of the cycle. So if there are no safe actions, then just keep going forward. Otherwise, we're going to return a random index from safe actions. Easy, right? Now, the last thing, which is a little more complicated, is the go straight until you're about to hit something AI. But it might seem more complicated, but it's actually quite simple. So what we're going to do is we're going to wanting to keep going straight. So going straight is going in the same direction that the cycle is currently going, whether that's up, down, left, or right. So if I get the direction of the cycle's current direction, right, then I compute the next location, which is adding the direction's X and Y component to the cycle's X and Y component. And then I can ask if the new location, so if I continue straight, if that is safe, then keep going in that direction. Otherwise, if it's not safe to keep going straight, then I want to take a random safe direction. But rather than computing a random safe direction here, I just wrote an entire AI which computes random safe directions. So what I can do here is be lazy or be modular and write the AI that I wanted, right? So I'm going to construct the Tron random safe AI and then ask it for its move. See how that works? So it's super modular. If at any point I want to get a random safe action, I can instantiate the random safe AI and get the action that it would do. Rather than taking all this code and pasting it down here, we essentially just wrote a class that does it for us. Okay? So what you have to do for this assignment is write your super duper fantastic AI that beats those AIs and hopefully wins the in-class competition right here. Write your code here. And it just returns an integer. Okay? So that's assignment 1. And I know we went a little bit over time. I just wanted to go slowly to do that. Oh, the last thing I wanted to share real quick is how we actually get the AIs from the config file. It's the dumbest thing ever. It's super hard-coded. So when it reads in the config file, it gets a name for an AI. And down here, what I've done is simply a big if-else statement, and it says, if the name is student, return this, a new Tron AI student. If the name is random, return the random AI. If it's random safe, return the random safe if it's straight there. So when you eventually have all the assignments submitted to me, I'll probably get 30 to 40 of them, hopefully. What the TA is going to have to do is write this using your usernames. Okay, so that's why you have to put your usernames in there, because I'm going to make a big config file of all the students in class, and that's how that's going to work. Okay, so you shouldn't have to modify this, but you do want to modify that. Perfect. Okay, so back to here just for a second. So that's assignment 1. We went a little bit over time, but that's okay. Assignment 1 is due 2 weeks from now. That is plenty of time to do assignment 1. Just try and do as good a job as possible. It's the simplest assignment. They will get exponentially harder from here. Not too hard, because I'll explain how to do them. But this is just like, can you work with vectors and arrays and stuff in C++? I had one question in the chat. So our AI should do significantly different movements than the 4 examples. Yes. If it just does something random, I mean, you haven't done anything, right? So it has to do something significantly clever. So try and come up with something clever. And it also has to beat the default AIs. And you can't just like take part of one and add it to another. I want you to actually think. Okay, this is an AI course. This is the intro, and you can't get full marks in the assignment unless you do well in the competition, right? So, okie doke. That's it for today. On Thursday, we'll get into the real start of the AI lectures part of the course. And for anyone out there who's not in the course, you can hit !course or playlist to follow along with the course on YouTube. Okay, that is it from me. Thanks for tuning in, and I'll see you on Thursday.